This video is about the Analysis API, and we're going to look at what symbols are and the information that they provide. This video is part of a series where I'm speaking about different pieces of the API. So let's take a step back and look at the different phases in the Kotlin compiler. So this is an overview and a review of different phases. The Kotlin compiler takes your source code and it builds something called a PSI tree. Each node here represents an element in your source. But there is information that's not in this PSI tree. This PSI tree is just a syntactic representation of your source code. This is where analysis comes in which semantic analysis is done and information is added. This is where the compiler takes a step back and looks at the overall relationships between different elements in your source code, looks at different scopes in your source code, and it figures out and does type inference. So let's start by looking at a very simple example and how to use the Analysis API, what that and get symbols. So here I have a very simple abstract class and an implementation of it, and I'm overriding the check method. The first thing that will happen is that I could create a PSI tree which looks like this, and each element here represents an element in my source. At the root you have a KT file. So when you look at this PSI tree, I could grab one of these elements and provide it to the Analysis API. Suppose I were to provide to the Analysis API the root element, which is KT file. And when I provide this to the Analysis API, the analyze method, what I get back is a result. When I provide it to the analyze method, it allows me to grab information by accessing certain extensions. It gives me semantic information through those extensions. So the Analysis API is designed on top of the PSI elements, and all the information, semantic information that it figures out is accessible through those extensions on these elements. So let's look at an example. Suppose I were to take a KT element like this and then provide it to the analyze method. This is what the analyze Kotlin Analysis API looks like. And it starts with this analyze method, and it gives me access to symbols like this. So symbols right there is an extension on that element. So what this Analysis API looks like, this analyze method internally, is this method right here. This is the source for it, and it's creating something called a KA session. So let's break down each of the different pieces of this analyze method. The first parameter of this analyze method is a KT element. So I could provide it with one KT element, but I could also give it a module, KT module. I could give it which module. The module could contain a bunch of KT declarations, expressions, and I could do analysis by providing this module. One thing to note is that if you look at the Kotlin Swift export tool, it builds, for example, a Swift module and provides it to the Analysis API. So when you provide this to the Analysis API, I could grab information of all the declarations in that module. There's an API to build this module. So the next thing to note here, which is very, very important, is this action block right here. What it does is that it internally builds what we looked at in the previous video, a KA session, which is the entry point for analysis. So one thing to note here is that, for example, when you look at the Kotlin Swift export tool, they have something called an SIR session. So this is a KA session. One thing to note on the nomenclature is that all of the types, like KA types, KA session, they all start with this prefix of KA, which stands for Kotlin Analysis. So this action block allows me to basically get access to the extensions on the elements which have semantic information. So a KA session, which is the entry point, is made up of providers, is made up of checkers. It's an interface internally. So the Kotlin Swift export tool, for example, has an SIR session which has providers for Swift and checkers for Swift. And in this example, They also have providers and checkers for Kotlin. So the KA session is an interface made up of these different components. So when you look at the analysis API, you could provide it with an element or a module, and you could grab information. In this case, I'm getting the symbol. A symbol underneath the hood is represented by an interface called a KA symbol. And there are different types of symbols that I could get access to, for example, for a function, a variable, etc. So this KA symbol is very different than like a PSI element, like a declaration, for example. And let's look at these differences. A KA symbol and a KA declaration, one of the things that's different is immutability. A KA declaration is mutable, so I could mutate it, I could add information to it. But a KA symbol is, for example, a KA symbol is immutable. So when you look at a KT declaration here, I could change things such as the name, for example. I could add children to it. And I could add variable value parameters. I could add new parameters to it. Whereas a KA symbol is immutable. What that means is that whenever I do a mutation, there's a new KA symbol that gets created every time. So a Kotlin analysis symbol is immutable. And let's look at that much more closely. Suppose I have a KT declaration and I order to change the name. Underneath the hood, what happens is that it's going to generate a new symbol for me. So those are the two differences between those things. So a new symbol gets generated. The next thing, which is the difference between these two things, the symbol and the declaration, is the source. The declaration represents the source structure. It represents what the source looks like in the PSI tree, whereas the KA symbol gives me semantic information. So when you look at this, right there at this code, you looked at the PSI tree right here. Each of the elements represents an element in my source. So for example, the KT name function right here represents the overridden function. And this is the overridden function in my implementation. When you look at the information which is missing in my implementation, that it's protected. And when you look at this information, what you'll see is that the visibility is also null. So I don't get access to information about the visibility. This is where the analysis comes in. And in the analysis, I could ensure that this function is protected. It has to look at the overall code relationship in order to figure this out. That's what analysis does. So that KT declaration represents the source structure, but the KA symbol gives me semantic information regardless of the origin, as we just saw. We could get visibility information from the analysis and ensure what it is. So how do I get information about the visibility of an element? Just like this, element.visibility. So, and what it gives me is information such as that's protected. Visibility, for example, is an extension on this element. And this is how the analysis API works. So we have, what does the structure of the hierarchy of KA symbols look like? So I could get a file symbol, a package symbol, declaration symbol, or a callable symbol if I'm calling a function. So all of these, the root interface is a KA symbol, but then I have these inherited interfaces. So I have a file symbol, package, and I have a call symbol. And all these different things give me different information, and it's all dependent on the type of KT element that I'm analyzing, that I provide to the analyze method. So this is a overview of what symbols are, and they're very, very useful. And the next thing we'll look at are analysis types. Then we'll look at resolution and diagnostics.